Good morning, everyone, and welcome to this new video. Today will be the first lecture of our chess project, where we will build a fully functional 3D chess in Unreal Engine. But to first get the basics right, we will start with building a console program and integrating a Stockfish application in the background. You might wonder why I start this way around. I can tell you easily. I want to show you how C++ differs from Unreal Engine C++, and then I also want to show you how blueprints work in Unreal Engine, so we have the full amount of information and all stuff available, at least captured once. We also will have a look at the Stockfish engine, as I mentioned, because it helps us not to code all the chess rules and stuff like this, but instead communicate with it very easily. And then we are able to just rearrange the field, and it will calculate every possible move, every legal move, every best move, and so on for us automatically. For this, we will have to use FEN strings, which I will tell you about in a second. And then we will be able to use not just a player against player chessboard, but also AI versus AI and mixtures of that. So without further ado, let's head right into it. So this is the first time you see the console program, and this is how it will look like. So we will first enter a name. Now we will tell the engine if we want to play against the AI or not, and then we will define the skill level. Afterwards, we can just decide whether we want to start or the AI wants to start, and then this chessboard representation will be printed, and the legal moves will be shown, as you can see here. We also have the FEN string for the first time here, which I will explain in detail a little bit later on. And we will see that I am the first one who makes the turn, and I only have the legal moves which are allowed to enter. With that being said, we can start with having a look at how the chess engine actually works. We have a few relevant files and functions here, and I want to show them all to you in detail. But before we do that, I want to give you a quick overview. So let's move my camera out of the way. We have first the FEN parser, which is able to parse a FEN string and extract every part individually. That will be done in the next lesson. Then we have the Chess AI handler, which has a function called getChessAIFeedback. It sends the request to Stockfish and receives a specific type of answer, which we can then decode to get the current board position and stuff like that. And the console chess itself, so consolechess.cpp, will contain all the functions and everything that is necessary for the console interaction, which we will do 2 lessons from now. So that's just a quick overview. Let's go further on with Visual Studio itself, so I can show you exactly how it looks in code. Ideally, you've already opened the folder, which I provide in the description, or you can just download it from the SharePoint. And this is how it should look like once you extract it. So what do we see here? First of all, we have a Stockfish folder. Then we have the already mentioned Chess AI handler. We have a CMake lists. You might wonder what this is about. CMake lists basically contains everything we want to compile. And we will use CMake because it's not platform dependent, and we are able to compile it on Mac OS, Linux, Windows the same way. CMake presets is also a part of the CMake project. And then we have the consolechess.cpp, which I already mentioned as well, that contains every function relevant for the interaction with the console program. Then we have the FEN parser, which we will write in the next lesson, and stockfish.cpp. Let's have a look at the Stockfish folder itself. It's containing Linux, macOS, and Windows versions of the Stockfish engine. You might wonder, why did I prepare that for you already? Because you could just go to the download section of Stockfish. So if you just enter stockfish.org and click on the download here, you will see you can download it for Windows, Android, macOS, iOS, and so on. But why did I prepare it for you? So that's a question in general, whether you want to use an API, which can change anytime, and once it changes, dependencies might get corrupted, so you can have problems to get an actually working program again, or you just use something locally running, and you will be able to communicate with it basically every time, if not Windows or macOS messes up something when they create an update for it. So that's why I decided to give you those engines. As you can see, those are the executables here for Linux, macOS, and Windows beforehand, because you will always be able to run this code if not something very big happens. Great. Now we can have a look at how we can open it up in Visual Studio. I use Visual Studio. You can open it in any development application you want, but I will just use Visual Studio for the purpose here. It's also good because it will be used by Unreal Engine for the compiling process, so you will have to install it anyway when we get further into those tutorials. And let's go into how we can open it in Visual Studio. First, right-click into an empty cell here, and then click Show More Options. Then you go on Open with Visual Studio, and you will see the whole project opens up. That will take a little while, but I can tell you what happens. You can see down here, CMake is already compiling what we want to have and building our application. So when we click onto the console chess.exe up here, we can just click on it, and you can see it builds it for us, and this is what we should see. So we have no player details implemented yet, and the game loop is not implemented yet. There are also a few other things missing, but we will be finished with this in the next 2 lessons. Well, so where can we find all the project files now? You can see them already on the right side here, and I will just show you stockfish.cpp, because this is where Stockfish is located in. So let's click onto it, and you will first see that we have some libraries we just include, and then we have a path here. This path has to be changed. You have to change it to the path where your executable is located in. So in my case, this would be either in Visual Studio Code or in your file explorer. But in Visual Studio Code, it works like this. You just click onto Stockfish Windows for me, then you click onto stockfish.exe, and then you just copy the path. What you will see is, when I include it, it has just one backslash here. And that's not working with Windows. So if you're using Windows as well, and also maybe in macOS, I'm not quite sure about that, you always have to use double backslashes. Okay? So just make sure that you use it like I do here, and you just put every backslash into a double backslash instead. Right. With that being said, we can have a look at the Stockfish program itself. Don't worry, it will get a little tricky from here, but I will try to capture it as easy and as convenient as possible. Right. Those 3 options here are used for a singleton instance. So what is a singleton about? When I first started this project, I had multiple crashes of my GPU, and I was wondering, how can that happen? I have so much RAM, and I don't know why exactly there should none be available anymore. Yeah. Once I had a look at it, I had around 300 instances of Stockfish running in the background, and my PC collapsed, of course. So to ensure that only one instance is running, at once, we have the so-called singleton pattern here. So you might also wonder why exactly we have two types here. So we have the if-def and the else. That's because I wrote this whole code to be platform independent. So if you're on Windows itself, it doesn't matter if Windows 64 or Windows 32, you will get into this loop here. And if you're on Mac OS or Linux, you should go into this loop. Why is this the case? Of course, Windows handles things differently, so we have to also ensure that we open it according to the platform. Right. Then we start Stockfish if something is already return and do nothing. Otherwise, we just create the executable and we will create a pipeline to communicate with Stockfish. That's the same for Mac here, so don't worry too much about it. It's just how to create a pipeline and how to be able to send commands to Stockfish and receive an answer, right? So then we configure the Stockfish options. I want to have Stockfish running at 2 threads. I also want Stockfish to have a specific skill level, which I can put into it, so I can parameterize it here. And then we just have a little sleep, so we have to give Stockfish a little time to initialize. We also have the option to send a Stockfish command. This is just we write a string for it, and it will do everything automatically. Don't worry too much about it. And also a small delay at the end, so it is able to process it in time. Then we have the read Stockfish output. Stockfish, of course, provides us an output as well. So we first create a vector and line, which contains strings. And maybe I have to explain that first. So you might know arrays, but you have to set a specific size of an array. So for example, an array has 8 places where something can be located at. A vector instead is an unlimited array. So you have no problem at all always pushing stuff into it. It will never get an overflow or something. And you have to make sure the type of the vector is correct. So in our case, we want to have strings. So basically unlimited amount of strings located in an array. And that's exactly what we want to do here because we don't know how much strings Stockfish will send to us. So how its answer will look like. And that's just to make sure that we don't exhaust our memory or stuff like this, right? Then we have a buffer. The buffer is just used to not just store it temporarily, but also to read from it. And then we just have this line here, which is interesting. We just read the output of Stockfish, and if nothing is there anymore, or if it's not successful, we just create an error. Otherwise, we just push the line which we received back into the lines array, and we go on with listening to Stockfish once more. Then we have the get Stockfish results, and first we send a command, and then we have 3 things we send to it. UCI is ready and the D command. And this is a little bit of a tricky part, so I will skip that for now, and we will have a look at it specifically later on. Then we have a request to Stockfish, so we first started with a specific skill level. And we also need to provide a FEN string, which we already heard about, but not in detail yet. So how do we calculate or what do we use the skill level for? It's used to determine the depth. So how far into the future Stockfish should look like. In this case, we have 0.5 times the skill level. So if we have a skill level between 0 and 20, so let's take 20 for example, we have a depth of 10. So it will look 10 steps into the future. Then we have also to provide him the current position. And these are 2 commands which I will go into later because it's relevant for us. Otherwise, we just return the response, and that's the response we get from Stockfish. And we can close Stockfish to avoid having multiple instances. That's the Stockfish command for now. Sounds quite complicated, I know, but if we just click at Chess AI handler, you will see it's not that complicated because we have the instance of Stockfish here, we have the possibility to close it, and this is everything we use. So we have the get chess AI feedback. We just tell him which scale level we want and which position we are currently in. And we will automatically get the response here and don't have to worry any further that we have to look into the Stockfish code at all. We just get this response and then we will be able to extract it later on, but I will show you this in a second. What I want to show you first is the API of Stockfish and how it looks like when you open up the Stockfish executable and communicate with it. Great. Now that we've seen the Stockfish code in the program, we can actually have a look at the Stockfish API documentation. So we once more go into stockfish.org, just go into here, and then you will have the different options up here. So what's interesting for us are the docs here. So we just click onto it, and then we can see how to download Stockfish, how to download an GUI. That's also something we won't use because Stockfish is normally used together with a graphical user interface. That's what GUI stands for. And then you just have to include the Stockfish exe into it, and it will do everything automatically. But since we use it in a console program, we have to extract it ourselves. Right. On the left side here, you can see different stuff like Stockfish FAQ. But what's interesting for us are UCI and commands. So we click onto this. And now you can see we have the UCI command, which I mentioned earlier. We have the Z option. So for example, Z option threads value 6. That's what we already did. And we also have the option to, if we go further down, give the position towards Stockfish. Then we have the is ready. That's also what I've already shown. And the go command. And those commands have something different in mind. So what you can see here is also something bench-like. We don't use that. We just use go. We need UCI. We need position. And we need the is ready command. And of course the D command, but that will come up later. So this is how it looks like in the API. You can always have a look at it. I will provide the link towards it in the description. And now we can have a look what those commands do with the Stockfish engine itself. So for this, we just open up our, oh, that's the My Videos folder, sorry. So we just go into projects, student version, console chess. Now we go into Stockfish, Stockfish Windows, and now we click on the stockfish.exe. We click on more info, run anyway, and it will open up. This is what Stockfish looks like. So what happens if we enter UCI here? You can see those are all the things inside Stockfish currently. So we have a lot of stuff like threads, and it doesn't matter that much what's in it already. So if we send it is ready, it should answer with ready, okay. Right. You can see that here. So if we go further on, we have the D command. That's what I told you. So let's enter it, and we get this out of it. So first, our board representation. And now we have to know what FEN is all about, because all those things here are names for different chess pieces. So we have the rook, the knight, the bishop, the queen, the king, and the pawn. And the color is determined by its caps lock, for example. So in this case, we have P, so the uppercase letter means that it's a white piece, and lowercase means that it's a black piece. And we also see the FEN string down here. So that's why we have to use the FEN string to communicate with the Stockfish engine. I told you we can now go on with what commands can we enter into it. So we have the option to set options, of course, but we will skip that for now. Now we have the position. And what happens if we enter the position FEN 0, 1? So now we move a pawn one field ahead. Let's do that. We just enter it in here. So like this. And, okay, it's an unknown command because I missed something here. It is position FEN, and then we have to enter this. And now we don't see anything. Why is this the case? Because we haven't printed what happened before. So once we hit D again, we can see that the chessboard didn't change at all. So let's go with this instead. Let's copy this and enter it once more. No, that's a few lines. I don't want that. I just want this one. And what you can see here already is how we plan to use the FEN string, because this is the position here. And now we can add moves, and it would automatically calculate the board position after each move for us. So let's enter this into the engine here. And you can see nothing changes, but when I hit D now, we will see that's how the field changed. And you will also see the FEN string, which was like this here, is now looking like this. So all the moves got calculated, and we don't have to worry about anything more. What's more interesting is also that we can use the go. Let me see here. We have the go command, and we use go def and go perfed. So when we use go def 10, for example, you will see what happens. It will calculate us the best moves which we can do. So you can see it down here. The best move is c7 to c6, and then we follow it up with d1 and b3. I haven't included a ponder move, so the follow-up move inside the code, but we will always use the best move for the AI to work with it. We can also set the level of this best move to the skill level. So when we provide a lower skill level, it won't be able to do the best moves anymore, but maybe just a move dependent on strength. And this is why we build this whole thing up like this. What is go perfed now? When I go perfed 1, you can see we get so much information. So we have 33 nodes searched, and the perfed is used for the legal moves. So those are all the legal moves from the current position. All right, now this should make a whole lot more sense. So we have the board representation here. You now know where it comes from. Then we have the legal moves. You also know now where they come from, but we have ordered them differently here. So we also have to check how we extract them. Then we have the FEN string, which we just take from it. And then we have whose turn it currently is, but that's not part of the Stockfish response anymore. All right. With that being said, we can just go on to the chess AI handler. So how do we get the feedback now? We request it from Stockfish using the skill level and the FEN string. And now we extract the response. So we just have different variables here. And for now, we will just go with this part. So we have the response, and then we iterate over the lines. And now a quick question. Maybe take a few seconds here and pause the video and think about how exactly we can now check for specific strings inside of this information. So how can we find out whether something is a FEN string, a best move, a legal move, or just a board part? Right. Good. Have you thought about it? Otherwise, I will start now, so feel free to pause anytime. And let's go on with how we can check for the FEN string. What's interesting for us is to check how patterns work here. So not programming patterns or program design patterns, but patterns in general. So for example, we have the FEN pattern here. So the FEN string, and then the FEN string is behind it. We also have the best move here, just as a word, and then we have the best move in the position after the space. When we want to have the legal move, We just have to look out for the double dot one pattern here, which is behind every legal move. And that's exactly how we can determine what we have to do right now. So which of the parts we're currently dealing with. And if we check for FEN, I already told you, if we don't have, if we have the FEN double dot and then the space, it's currently a FEN string. And then we just want to use everything from the fifth position. So in informatics, we calculate from 0. So we have 1, oh no, sorry, 0, 1, 2, 3, 4. And now we want to have everything behind it, which is exactly the FEN string we want to have. We also can determine whether it's a white turn if the FEN string contains a W at this position here. White is currently drawing, otherwise the black chess piece would be moved. Right. Then we have the best move pattern, I already told you. So what do we want to have here? We want to skip the first 9 letters. So let's take a look at this as well. 0, 1, 2, 3, 4, 5, 6, 7, 8. And we want to have 9, 10, 11, 12. So from this position on, we want to have the next 4 letters, and that will be our best move. So this also skips for us this part here. Sorry, this part here. And that's exactly what we want. We want just to have the best move, not a ponder move or anything like that. Check for promotion piece is something I implemented to be easier able to identify when a promotion happened. So we skip that for now. And now we have the check for the legal moves. So we have to find the double dot space 1, which looks like this here. And if we find it inside one of those lines, and we don't find node inside of it, because that would be this pattern down here, or it could also happen that node is mentioned in here, and then you have node double dot space 1. So we don't want to have this either. Then we will only take the first 4 letters. So in this case, those 4. And this is exactly how we can extract all the legal moves, best moves, and so on from our response. The last part we have to check for is whether it's a word part or not. So what you can see here is that we check for the plus, minus, 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 plus, and space. I don't know exactly what this is called, but this upward line, and then space again. And then we also check whether or not it has something like this inside of it. And now we can check why this is the case. So when we have a look at our board representation, we can see this pattern simulates a board part. This pattern also simulates a board part. And all the other patterns, which I showed you currently, so this pattern here shows a board part, this pattern here, except like, oh god, here, this pattern, and this pattern down here as well with the A shows the board part. So this is the 3 different options we have to cover. We also want to have the A included because otherwise we wouldn't have that printed out. And that's exactly how we can extract all the responses from our FEN string. To just print it the way we want it to be printed, we can now use the best move and just print it. We can also use the legal moves and just loop through it and print them behind each other. And we can also print the FEN string. What you can see here is that we want to print it in blue, we want to print it green, but that doesn't matter that much. That's just for the colors. And then you have something like this printed out of the previously not really easy to read answer of Stockfish. Amazing. Now we have everything which we need in one place. Now we just have to end the session with a little bit of theory so we know why exactly, and sorry for keeping that so long, but I didn't want to make it too complex, what exactly FEN is and why it's so useful for us. We've already seen we use it to provide a board state, to the Stockfish engine, but what does it capture actually? And that's what we get into right now. Here a quick review of what the actual functions were we had a look at. We just had a look at a Chess AI handler for today, so you know now how to get feedback from Stockfish. And the next lesson we will go on with FEN parser and console chess. That will be the next 2 lessons. And then we will be able to use the full console program. Now, what is Stockfish and what is FEN? So Stockfish is the currently strongest chess AI. It uses lookup tables and neural networks to process moves. That's why it's so good. It's also very, very efficient in terms of time and processing stuff. So it's perfect for our usage. That's why we exactly use it for the calculation of the board state changes and the possible best moves. I already showed you the relevant documentation. When you hover over it, you can see it's the UCI and comments section of their Stockfish GitHub repo. So we can skip that for now. Have a look at it when you want to. You can also go always to their website and have a look at further details. Let's head to the FEN notation. The FEN notation, and I will just move my camera out of the way for now, is the so-called Forsyth Edward notation. And it's a notation of the whole board state. What you can see on the left side is how it looks like if you note any of the moves possible from this position and every previous move. You can see it gets quite large, and that's exactly why we want to have a notation that contains the whole board state. And thus, it contains implicitly every possible and previously made move as well. So that's the perfect option for us to use it as a parameter for Stockfish and to populate the field later in Unreal Engine. And now we have to look at what FEN is exactly about. First of all, if you want to have a detailed explanation, please follow this link here. They made a very good tutorial where everything is explained in detail. I will just give you a little overview of what FEN exactly is and why it's useful for us, and we will head further into it in the next lesson, okay? So this is how a FEN string looks like. We have the board state in red here, and it contains not just the board state, but the whole current board state. So every move that had been made, every rotation, so such as castling or stuff like that, that had happened. And it also contains the current color, which is orange in this case, and that's the color which can currently move. It can either be white or black, as you can already imagine, and thus only W or B can be in this position. Castling itself is whether castling on one side or the other side is still allowed. So there are a few rules you have to know about castling. And castling always happens to the king or the queen side. So you can see that both options are available for both sides here. So that's what we capture here. So we know that both sides are able to do a castling into the direction they want at the current state. The en passant rule is a little bit more tricky. So let's just keep it for now, whether an en passant is possible currently or not. It could either be a minus like here, or it is a specific field, something like E3 or stuff like that. And this tells us whether or not we can do an en passant. The half moves are only there to determine a possible draw. That includes if someone got rid of a pawn lately and stuff like this. But if you want to have a look at it, just go to the detailed further information. Otherwise, I will provide it to you in the next lesson. And we also have the full moves, so how many moves each side made. So this number goes up when both white and black have moved. That's all. So as you can see, the standard FEN string helps us a lot with determining how our current board state looks like, and also includes everything we need to know to give Stockfish enough information to determine which best move, legal moves, and so on are allowed from the current position, and thus it is the perfect opportunity for us to use for the interaction with Stockfish. So you know UCI now, which simulates a connection. Then we check if this connection is okay with using is ready. With D, we can draw the current state. So you saw the board representation and stuff like this. And with the set options name, and then we name the option, such as threads value 4. We set 4 threads to use. Otherwise, we can set the skill level and stuff like that. The board state can be changed by using position FEN. So we initialize a FEN position to initiate a certain state within Stockfish. And if we add moves, A2, A3, for example, behind it, it will also calculate the next current board state. And there are multiple options possible here. So you can do either one move or 20 or whatever you like. Stockfish will calculate it for you. And now let's move my camera out of the way a little. And the last part is how we can get the best moves and stuff like this. So we have the moves here. We search for the best move by taking into account the next 10 ones if we use go death command. And if we say go perf 1, it returns all the possible moves based on the current board state, so the FEN string. So I hope you got a quick overview of what Stockfish and FEN is about and why I exactly chose this combination. And I hope you're already looking forward to the next lesson where we will actually code something from hand. I'm sorry that this lesson didn't contain any coding as well, but I want to make sure that all the basics and all the stuff of the interaction with Stockfish is targeted at least once inside this whole course. We won't need it in the next few lessons. We just need to get Chess AI feedback and we will have everything that we need from Stockfish. So that's the only lesson that contains Stockfish in general. And yeah, with that being said, I hope you had a great time and see you next time. Thanks for watching.